Can you see it now? Okay, so let's continue with our discussion with our ANACHEM class. I hope most of you are here and will participate in this discussion for today. We're scheduled until around 11:15, so let's make the most out of today's meeting, okay? Now, our discussion for today will focus on the basic equipment and instrumentation that we usually use in the laboratory for clinical chemistry or analytical chemistry laboratory. Huh? Can you hear me clearly, guys? Medyo nawawala ang signal ko ngayon. Dito ako sa demo lab. Okay lang?
Yes po, sir.
Okay, sige. So, to start with, no, let's look at different instruments. Okay, and today we'll be discussing instruments we use in measuring mass, volume, no, also in chemistry. Now, obviously, in just like anything in life, no, it's always good to have good measuring tools so that you have accurate measurements on whatever you want to measure. Okay. In chemistry, we usually measure in small amounts, no? Small amounts, minute amounts in grams or micrograms even. That's why we have to use very precise and accurate measuring devices. No? Hindi ka pwedeng gumamit ng mga hindi analytical tools, okay? Because the errors are quite high in those types of tools, no? Just like those tools used in the market, no, that could measures up to 50 kilos, no. Medyo tandaan niyo, habang lumalaki ang capacity ng isang bagay to measure, may that be mass or volume, the error also increases. Okay, so if you want to measure precisely, you measure it in smaller amounts using powerful and high precision tools. So for mass, the instrument use, okay, usually is your electronic balance. No? Everyone knows what an electronic balance is. This electronic balance can measure from around 100 to 200 grams with measurement capabilities up to plus and minus 0.01 or plus and minus 1 milligram. Okay? Ibig sabihin, it can measure up to the nearest hundreds. Okay? So it can measure, let's say, 1.01 gram. That could measure that. Usually, itong mga analytical balance natin, electronic balance, ginagamit sa laboratory, no? Because in the laboratory, as I mentioned, you always use small quantities of chemicals, no? Like in powder forms, for example, or in solid form. Okay? And by the way, sino na nakagamit ng electronic balance? Meron tayo dito marami. Sa lab, meron tayo. Now, what's crucial, no, in an electronic balance, no, it's its ability to tear the measurement, to have a tear. No? Tear na pag nilagay mo yung, for example, mag-measure ka ng 5 grams of salt. No? Siyempre, saan mo siya i-measure? You will not put your salt directly on the weighing scale, on the pan of the weighing scale, so you have to use a particular container, right? Like a small beaker, no, or a paper container. Okay? So, what you do is you put the container, syempre i-measure niya yung weight ng container, and then you just press tear, so that the weight of the container is no longer measured. So what you're measuring, the next measurement is only the product that you really want to measure. No? So yun yung tier na sinasabi natin. So adding a sample, no, in an analytical balance, no, pan down. No? So when you put the sample in the analytical balance, the balance will pan down, okay, allowing more light to reach the detector. So ito yung mechanism kung paano ginagamit yung analytical balance. Okay? So for example, dito, so you have a light source, okay? So underneath all of this mechanism, you have a light source that emits light into a detector. When you put a weight on the balance here, can you see my cursor? Can you follow the movement of my cursor, guys? I hope so. Thumbs up if you can. Okay. So you have a light source inside here that emits light and can be detected by the detector. Now, once you put something on top of the balance, obviously the balance will pan down, bababa siya dahil sa weight na nilagay mo, and then when that happens, um, yung this particular part, no, in the measuring device, will allow more light to pass. No? And based on the light that passes, doon ika-convert noon into numbers. Okay? So basically, what happens is when you are not actually in effect measuring the weight, but the light that is passing through or that is detected by the detector. No? So at the start, when you don't have anything, naka-block ang light. Merong light source, etong detector, merong naka-block sa kanya, no? Na metal. Pero pag habang bumababa etong fan, parami ng parami ang nagpa-pass through na light papunta sa detector, paakyat ang measurement ng device. Okay? So that's how your analytical balance do its job. Huh? So when you naman measure liquid, no, in any chemical laboratory, again, usually we measure liquids in milliliters, no? Bihira yung you measure liquid in large quantities like per 10 liters, per 100 liters, bihira sa laboratory, no? So we need to have accurate measuring devices to measure the volume of the liquid. To do that, we have pipettes, no, graduated cylinders. No, the graduated cylinder is a cylinder with different graduations. Yung mga lines na yan, each of that line is a graduation. That's why it's called graduated cylinder. And each graduation is a measurement of a liquid, right? So you have beakers from 10 ml beakers up to 2 liters, 2 liters beakers with a capacity of 5 liters even. No, we have that in the laboratory. You have burees. No, burees, when you do titration techniques, burees also have some graduations here that can measure how much liquid is being passed through the buree. No, so still you are measuring liquid. Okay, you have volumetric flask. The difference of in any flask from a volumetric flask is that in a volumetric flask, usually the bottom part is usually conical in shape, no? So that it could house more volume. At the same time, if you're heating the volumetric flask, the round bottom of the flask also will help dissipate the heat much evenly throughout the flask. We have Erlenmeyer flasks also that also have graduation. So most of this, if you notice, are made of glass, no? Glasswares. Kaya tinatawag natin sila mga laboratory glasswares. Um, these glasswares are these laboratory apparatus, no, or equipment for volume are usually made of glass because glass usually does not react with the chemicals that we use in the laboratory. No? That's why we use glass instead usually of plastic or wood or metal, no, which can corrode through time. Okay? So better yung flask because it's usually inert. It will not react to whatever you put inside it. Any questions so far? I'm sure you are all familiar with these types of glassware, right? Question so far? None? Okay. Next, we have, aside from those, no, mga flask, we can also measure volume. We can also measure volume through pipettes, right? Pipettes. You have a transfer pipette. You have a measuring pipette, no? This usually needs another device called the aspirator, the rubber aspirator, no, so that you could suck the liquid that you are trying to measure and then transfer it to another volume or to another container. And of course, we have mga digital pipette, no, micropipetors, no, micropipettes or digital pipettes, to measure much more accurately smaller volumes, no, in the quantity of microliters, like 1 microliter, 2 microliters, and so on. Okay, and of course, you also have syringes. No, syringes also have certain graduations that you could use to measure the liquid you are trying to pull out from the source or transfer to another container. Okay, so another basic technique that I hope that you are already familiar with is how to properly read your volume when you're using glasswares. No, obviously you measure it uh, sa lower meniscus. No, so proper means of reading the meniscus on a volumetric flask or pipette is you measure it sa lower meniscus. Okay? Remember, the liquid inside will cling on to the walls of the container. That's why you have this some sort of uh, uh, shape, no? Concave shape, because the liquid is clinging on to the walls of the container. Okay? Kung saan nila kayang mag-cling. That's why it's higher compared to where is the bottom. That's why when you measure and you look at it from the outside of the source of the container, usually you will see two lines. That the line above, the upper meniscus, is actually the highest point where the volume of the flask or where the liquid, no, is reaching. Yung pinakamataas niya na kaya niya magdumikit doon sa loob ng container. Yun yung higher meniscus. Ang lower meniscus is yung bottom ng line. That's why it's much accurate to measure it using the lower meniscus. Okay? Question? None? Okay, let's continue. Now, also in the laboratory, we also have to sometimes dry samples because in drying samples, usually ang gusto mo yung magprecipitate sa baba. No? So you want to discard the liquid part. For example, yung tubig ng sample mo. So you use a desiccator or any equipment that could dry your sample. So these are some of the things that we use in the laboratory if you want to dry your samples. You have a desiccator. It's usually a metal uh, a metal jar that looks like this. You put your samples inside, and then you could suck the air from the inside, no, sucking all the liquid or the liquid that evaporates from your sample inside the jar. No? So if you notice, meron ditong portion that you could put a hose in, and then pwede siyang i-suction, no, doon sa gripo. Okay? So you could parang i-vacuum mo ang loob nito. No? That's a desiccator. It's used to store samples in a moisture-free environment. So, halimbawa, gusto mo na yung sample mo na product mo ay always siya dry, tapos siya ay hygroscopic. Hygroscopic meaning yung mga bagay na pag nilagay mo lang somewhere na open, they will absorb the moisture from the air, no? Like salt, hygroscopic ang salt, di ba? It will absorb moisture. Okay? And you want your salt to dry, always be dry. You could put it inside of the desiccator because inside the desiccator, naka-vacuum siya, no? So the moisture will always be sucked out. Okay? So you could store your samples always dry. Another is your oven, no? A conventional oven that could heat up to 400 degrees Celsius. That's high, no? 400 degrees Celsius. So you put your samples inside, you heat up the oven, and then inside the oven, meron din siyang exhaust para doon lumabas yung mga nag-evaporate na tubig or whatever liquid that evaporates. No? So meron siyang exhaust sa likod or sa likod. This is used for drying materials, no? From around 90 to 400 degrees Celsius. Okay? So your conventional laboratory oven. And you can also use a furnace. Okay? A muffled furnace. I don't think we have a furnace here in the school, but a furnace is used for heating samples to a maximum temp of 1100 or 1100 to 1700 degrees Celsius. Okay? You use that to sometimes, no, if you want to check the melting point of a solid, no, and it's very high, no, you need a furnace. Okay? Um, it's just an oven, no, technically, that could heat. So, heat more than 1,000 degrees Celsius. Okay? So you could even melt metal inside the furnace. No? Imagine niyo yung mga gumagawa ng mga metals, no? Nag-melt ka og metals, no? That's a furnace. Okay? Furnace. Any question? Question so far, guys? Wala? Okay. Thank you, Jel. So let's proceed now. No? So when do we use all those things? No, that I just mentioned. No, those things to measure your volume, to measure the mass or weight, and then when do we use those things? No? So usually we use them. Number one, when you prepare solutions. Prepare solution. Now, by the term itself, solution is something that is a mixture of at least two samples, no? And supposed to be after the solution is mixed, no? When you have a solution, those two samples be at least should have the same should be homogeneous, right? So that's a solution. Okay, so uh, preparing a solution of known concentration is perhaps the most common activity in any analytical lab. Because when you buy a reagent from your source, from your supplier, usually the reagent being delivered to you is highly concentrated. No? Highly concentrated yung mga mabibili mo. Okay? Um, in the laboratory, you seldom use concentrated reagents, no? And so, the first thing that you have to do when you want to use the reagent is to dilute, dilute it, make a solution out of it. No? Now, um, the method for measuring a solute and solvent depend on the desired concentration units. Desired concentration units and how exact the solution's concentration needs to be. Okay? So ano yung concentration units mo? Would it be in molarity, in normality? No? Of course, you know that. Pipettes and volumetric flasks are used when the solution's concentration must be exact. So again, as mentioned earlier, if you want to measure small volumes, no, much with high accuracy and high precision, okay, you use pipettes and volumetric flasks. Okay? The smaller the volume it can measure, the higher its accuracy. So if you are using just graduated cylinders, beakers, no, bottles, these are just approximations. You could approximate the volume, but if you really want to have a very exact volume, accurate volume up to plus and minus 1 ml, then you have to use pipettes or volumetric flasks. Okay? Follow? So, in preparing any solution, no, you have to usually resort to first preparing a stock solution. And ano yun? Chat? May chat ba? Question? Is there any question? Someone. Okay, wait. Someone wants to join. I'm okay. So where was I? Okay, preparing solution. So prepare solution. You could first prepare a stock solution. No? A stock solution is something of known concentration from which other solutions are prepared. No? So sa laboratory, kung baga, pagdating sa iyo nung product, let's say it's halimbawa sulfuric acid. Bumili ka sa supplier mo ng sulfuric acid. Gamitin mo sa lab. Pagdating sa yung sulfuric acid, usually it's highly concentrated. Okay? Now, in your experiments, usually, if you're using acetic acid, sulfuric acid, you usually don't use concentrated sulfuric acid, 50% and so on. Okay? Now, para mas mabilis ang trabaho mo, you first have to prepare a stock solution. A stock solution is something that you prepare from the original concentrated solution, no? And then prepare that so that when you need other concentrations, you could just easily add your solvent like water. That's a stock solution. Okay? So a stock solution is prepared by weighing out an appropriate portion of a pure solid or by measuring out an appropriate volume of a pure liquid and diluting to a known volume. As I mentioned, pagdating sa iyo ng mga binili mong mga gamit or reagents, usually it's quite concentrated. Okay? So exactly how this is done depends on the required concentration units. So for example, 100% ang reagent mo na binili, 100% concentrated. Ang stock solution mo usually 50% concentration. No? So halimbawa, if it's pure liquid, no? Kung gusto mong maging 50% siya, no? Pwede kang kumuha ng 50 ml ng pure liquid and then you just add 50 ml of water, for example, to give you the desired outcome of concentration. Okay? So again, it's either you prepare a stock solution or there's number 2, preparing solutions by dilution. So solutions with small concentrations are often prepared by diluting a more concentrated stock solution. So as I mentioned, your stock solution comes from the original concentrated solution. From the stock solution, you could prepare new dilutions. Okay? New dilutions. So a known volume of the stock solution is transferred to a new container and brought to a new volume. Since the total amount of solute is the same before and after dilution, we know that the concentration in the stock solution, C sub O, and the volume of the stock solution is equal to the dilute solution concentration, the concentration of the diluted solution, times the volume of the dilute solution. No? So this is the ratio and proportion, kumbaga, no? CO VO is equal to CD VD. The type of glassware used to measure VO and VD depends on how exact the solution's concentration must be known. So if you need to have a highly precise concentration, you use more precise or accurate instrument or tool or glassware. No? That means you will use glasswares or concentrations or tools that can measure more accurately if you want more accurate measurements or concentration. So this is a schematic diagram on how you prepare a stock solution. Wait. Can you still hear me? Parang nawala na ako. Can we first take a screenshot? Kasi baka malubat ako, hindi ako nakadala ng charger. Can you open your camera please for a while? Kaya okay lang. Okay, sige. Let me just take a screenshot. Okay lang yung iba na hindi mag-open kung hindi kaya. Okay. 1, 2, 3. Hindi rin naglo-load yung iba eh. Thank you. Let me send it first to our group chat. Okay, so again, this is a stock solution. Now, how do you prepare a stock solution? So first, if you are trying to have a solution from a pure solute, an appropriate amount of the pure solid solute. If it's a pure liquid, no, then you also have to measure it using a good measuring device, usually a cylinder, graduated cylinder. No? And then, if it's a solid, no, you put that inside a beaker, you dissolve the solid into small portion of solvent, okay, and then transfer everything to a volumetric flask. Okay. Now, how would you know if you have achieved the desired amount, desired volume, volumetric flask, okay, so that you won't put any unnecessary extra solvent. Okay? So parang kung halimbawa, nagatimpla ba mo, nagapalit ba mo o ano, kanang mga litro pack, mga juice? Do you do that at home? Di ba uso na kanang mga packets ng 1 liter litro pack, ganon. No? So, pag bumili ka niyan, isang pakete, you put that in how much volume of water? Gaano karami ang tubig na dapat mo ilagay para sa isang litro pack? How many liters of water? Answer. So basically, isang litro, obviously, ano? So you need 1 liter of water. Yes, tama. So pag 1 liter of water, tapos naglagay ka ng isang litrong tubig, tapos gidissolve mo dito ang 1 litro pack na iced tea, for example. Pero naglagay ka pa ng ice. Pag natunaw pa ba ang ice, tama pa ba imuhang solution? Obviously, hindi. It will be much more diluted. Now, that's the same concept here. Okay? Yung stock solution mo, basically, is you put the desired total volume ba ng solute mo or weight ng solute mo, and then put that and mix that with your solvent. That's your stock solution. From that stock solution, pwede ka pang mag-dilute pa. Pwede ka pang mag-dilute. No? So, halimbawa, meron kang 1 liter of water, isang litro pack, dinsolve mo, pwede mong sabihin na yan yung stock solution mo. Pag naglagay ka pa sa baso, tapos nilagyan mo ng ice ang baso, you are trying now to dilute it further. Okay? Okay. Question? Nagreklamo na ang laptop ko, 13 minutes lang daw. So pag namatay ito, na-stop ang ano natin, ibig sabihin namatay ang laptop ko. Okay? And you will stop there. But meron pa akong 10 minutes sa laptop life ko. Okay lang, guys? Can I continue? Okay, so how do you prepare by dilution? So yun, preparing the stock solution. This is when you prepare your solution based from dilution. Okay, so you start with a known concentration of stock solution, and then you later, and then if you want to have a much more diluted concentration, then you do this. So this is your stock solution, for example. So transferring a known volume of stock solution into a large volumetric flask, okay? And then diluting with solvent up to the mark of the volumetric flask. So basically, ang ginawa mo is from a concentrated solution, from a known stock solution, dinagdagan mo pa siya ng solvent. Ibig sabihin, mas mababa ngayon ang magiging concentration. Right? Ano ba ang diluted sa Bisaya or sa Tagalog? Kanang gidilute ba? Kanang na labnaw? Tama ba? Labnaw ba na? Kung sa Bisaya pa, lasay na ang ano, nalasay na ang juice. Diluted na masyado. Sobrang dami na ng solvent. No? Hindi na proportional ang solvent sa solute. Kaya diluted. You always have to know the concentration of the stock solution and the volume. Okay? So C1V1 or COVO is equal to CDVD or C2V2. Algebra lang ito. Mukhang hindi na talaga kayanin ng laptop ko. Nasa 5 minutes na lang daw. Okay. Can we stop here and then we'll continue tomorrow? So, bukas guys, kung wala akong ibang gagawin na sasabihin ni Dean, we will have a class both for STS and kung meron kayong extra time. Okay? Sige. Can we have another... Wait. Can we have another screenshot for your attendance? Mga wala, okay lang. May mga tao pala sa labas. Okay, sige. No problem. Sige. I'll take the screenshot now. Okay na ba? Yung iba na naka-open ang cam, most likely hindi ma-open dahil kulang ang mahinang wifi. Okay lang. Sige, pakita. Para may ebidensya. 1, 2, 3. Alright. Bye-bye. Thank you. See you tomorrow, ha?
Bye, sir.
Bye, sir. Thank you po.
Salamat, sir.
Bye-bye.